A warm good morning, guys. Today we are going to solve yet another question, that is valid binary search tree. Basically, this is the most asked question in an interview or perspective, as well as it's a good question to learn and have a hands-on experience with the binary search tree. So I'll just make it clear that you should have a prerequisite of binary tree. What is binary tree? You should know about binary. You should know about binary search tree. What is binary search tree, and how does it work? So I'll just give you an overview how binary search tree works. For this example, you can see that whatever the root, right? The left side of the root should be less than the value of the root itself, and the right side of the root should be the more than the value of the root itself. As you can see, 1 is less than 2. Yes, the left side is good. You can go through binary search tree. As well as the right side is 3, that is more than 2. So the conditions of binary search tree are accepted here. And you can say that this is the binary search tree. Right now here, for this question, 3, okay, let's take this road, that is 4. So basically the left side is, of course, it is less than the root itself, and the right side is more than the root itself. So binary search tree, this current node is going through that it is a binary search tree. If we watch this one, that is 5. The left side is yes 1, that is smaller than the root itself. But the right side 4, that is again smaller than the root itself. But here the condition is that this value should be more than the root value, right? So here it not defines the value, and it breaks the rules of binary search tree. So basically we have to go through this and say, given the tree, we have to say that it is a binary search tree or not. So basically it is not uh, defining the rule and not going through the rules of binary search tree. So basically it is not binary search tree, and this is a binary search tree. So the output is true and the output is false. The explanation is given here that value 5 is, but its right child value is 4, right? So 4 is less than 5. It should not be defined like that, and so it is not a binary search. Okay, so yeah, we have done through this. And again, another prerequisite would be that you should know about traversal technique. Traversal technique of binary trees. That the three techniques are there for traversing. That would be in order, pre-order, and post-order. So what does the in order mean? In order means that even if you travel through the tree, basically the idea is you should first traverse the left side of the root, then to the root element traversing 1 to 2, then 2 to 3. This is the traversal technique. If you go through pre-order, what does pre-order mean? Pre-order means you have to traverse this two elements, right? Like root element, then left element, then right element. That is pre-order. What is post-order? Post-order means you have to traverse the left element, then right element, then the root element. That is post order. Okay. So let's try to solve this from in order perspective. What does in order have to do with it? Like let's say, let's say this is the case and we have to find the in order. What does the in order give? Like we'll traverse through left side, that is 1, then we'll traverse through root, that is 2, then traverse through right, that is 3. Okay. This is the in order. Okay, traversal. For first case, right? This for first one. Okay. So what is the second one? Let's traverse with this. What is in order for this, right? First we'll traverse to the left element 1, then traverse through the top element 5, right? Comma. Then we'll traverse through right element. But if we are traversing through the right element, you can see again it's the root. And again we have to traverse in order through this. So in order would be 3 in this case. Then again root is 4 and 6 is the case, right? That is how you'll get. So you can see for every tree you'll get the binary search tree would be what, like the increasing thing, like you can see here 1 is more than 2, 2 is more than like 1 is less than 2 and 2 is less than 3, right? This is how you can define a rules that if it follows this order, then it is a binary search tree. Binary search tree, it cannot it is not like just 1 2 3, but it can be 1 10, and here it could be 38 or something, but it should be increasing value. or it could be like 1 comma 1 comma 5 comma 7 comma 8 comma 9 comma 10, as it is increasing value, right? You can see 1 is same to 1, but it is increasing in a way, right? If this is the array we are getting, then we can say that this is a binary search tree. But here you can see 1 is 5, but you can see that it is not in increasing fashion, right? You see 1 5 5, after 5 it is 3, it is decreasing. So basically in this case you can say that it will output false because it is not in an increasing manner. That is what we have to show. Okay, so let's try to code in, and I think you'll get a perfect idea about what I'm saying. Let's first get out the node, comma, the array. Okay, if node not equal to node not equal to none, right? Node not equal to none, then what you have to do? You just have to go to the left element, right? So what is the left element? It's node dot left, not a node dot left, comma, array, right? And you just have to array append node dot value, and after taking the node dot, you have to go to the node dot right element, comma, array. Okay? This, and as we are traversing to the left element first, then we are appending the node value of left, then we are traversing to the right element. That is what we wanted. Okay, okay, we got that. Have to turn here array. Okay, as we want the array itself, we are returning. After returning this, you can say if node not equal to none. Okay, if node is, oh sorry, root from here because we are taking a root. So if root is not equal to none, okay, for everything we have to go and check if it is working or not. Or you can say that no, not like that. You just have to give the value. So I think is valid BST is given in order, give the root, comma, give the this. As it is returning the array, so let's take as the array 1 and get the array. Array would be array 1. Okay. So for I in range length of array 1, if it would be from first element, if array 1 of I is less than whatever that element, if it is less than array 1 of I minus 1, yeah, then return false or return true. If it is less than, okay, then return false. But it could be equal. No, it could be equal, but if it is less, array is not defined. Did you mean array 1? But where is the array? Okay, yeah, array 1. Okay, it would be less than and equal to, because this should be less than or equal to, then return false. Expected should be false because, yeah, it is 2 to 2, same value. That's why. Yeah, it should be in increasing fashion. It should not be same, right? Okay, I got something wrong, but yeah, that is basically how you should go. 93.76%. The runtime is much more faster than I expected, but yeah, that is how valid binary search tree. Thank you, guys, and I hope that you have understood what valid binary search tree is and how easy the code is to write and how you can solve this question. Thank you.